What's up YouTube, this is Nivan Gadral, and if you've been following my YouTube channel or Medium for the last year, you've probably seen me make a lot of AI content. Probably way too many. Yet through all of these AI videos and articles I've wrote, I've never really talked about the basis of AI and how that actually works. So let's do that now. If you're watching this video, then you probably have a computer, smartphone, or any device. So then probably you've experienced AI in some form. Artificial intelligence is where computers demonstrate behaviors associated with human intelligence. AI is a vast field found from impacting healthcare to agriculture. At the heart of AI, there are neural networks. They can easily find patterns in data which would be harder for humans to do. They also set the basis for other models to branch off from and use for more specific analysis. In a neural network, there are three main components: input, hidden layer, and output. The inputs are the values that are given to the neural network to complete its function. The hidden layers complete the function by using some of the values which are given by the inputs. There can be multiple hidden layers in one neural network, but this depends on what the neural network is going to be used for. The output is the end result after all of the functions have taken place. The line that connects the inputs to the hidden layers are called synapses. Each synapse is assigned a weight that decides which signal is the most important. Let's imagine that the input and the hidden layer are like a train station. The synapses are the train track, and the signal is a train. The train goes on the train tracks from one station to another. Let's imagine on the train track there's a lot of trains going through it, which has caused a backup to occur. To make the train start moving smoothly again, the weights will let the most important trains go through first, and then the less important trains will go through second. Each circle in a hidden layer represents a single neuron. In the neuron, all of the values that are linked to that neuron are added by their weighted values. After all of the values are added together, an activation function takes place. There are many types of activation functions, but there are four main ones. One type of activation function is called a threshold function. On the x-axis, there's a sum of the weighted values, and on the y-axis, there are the values from 0 to 1. The way this function works is by giving an output of 0 if the sum of the weighted values are less than 0, and gives a sum of 1 if the sum of the weighted values are greater than 0. This function is most commonly used for yes and no scenarios. Another type of activation function is called a sigmoid function. Just like the threshold function, on the x-axis there's a sum of the weighted values, and on the y-axis there are values from 0 to 1. Unlike the threshold function, this function has more of a gradual progression, unlike the threshold function, which goes from one to another right away. If the sum of the values is less than 0, then the values will be approximated to 0. If the sum of the values are greater than 1, then the values will be approximated to 1. This function is most commonly used to predict probability. The third type of activation function is called a rectifier function. Just like the threshold and sigmoid function, on the x-axis there is a sum of all of the weighted values, but the y-axis does not have a limit and continues to go up. The function starts at 0 and gradually progresses as the x increases. This function is the most popular function that are used in neural networks. The last type of activation function is called the hyperbolic tangent function. Just like the previous functions on the x-axis, there is a sum of the weighted values, but on the y-axis, it goes from both 1 to 0 and 0 to -1. The function is just like the sigmoid function, where it has a gradual progression, but this function also has negative values as well. Now that we know how neural networks work, how do we actually train them? To train a neural network, there are two types of outputs, the actual value and the output value. The output value is the value that the neural network gives out based on the input value. The actual value is the value that should come out from the neural network. After the values go through the neural network and get the output value, it then figures out what the cost function is. The cost function is like the mistake that the neural network made in trying to predict what answer it is. The neural network then needs to lower the value of the cost function because it will make the neural network more accurate. The cost function will be fed back through into the neural network, and the weights will be updated, and the process repeats until the cost function is 0. This is similar to how a student learns. If a teacher asks a student a question, what is the capital of the United States? And they respond Boston, the teacher would say, no, it is Washington, D.C. The student will then look to see what mistake he made in trying to give the answer. And then he realizes, mix up Boston and Washington, D.C. So next time when he gives the answer, he will say that it is Washington, D.C. To find the cost function, a process called gradient descent occurs. Gradient descent is a way to lower the function to find the correct weight. In order to understand this process, let's imagine a ball at a position where a current weight is at. It works by starting at a random weight and then finds a slope at the point. If the slope is negative, then the graph would be going downhill and the ball would roll down. When the ball stops at a point, it will then find the slope again and repeat the process until it reaches the center. This is basically how gradient descent finds the right weight that would work. Let's just recap what we learned. Neural networks take input that they then process through an activation function, which is specifically used for the task at hand. For the neural network to train, it tries to lower the value of the cost function all the way down to 0 with methods such as gradient descent. Neural networks have helped complete many tasks that are related in finding correlations in data. They also build the building blocks for many other models, such as RNNs and CNNs. RNNs are used to find correlations in data over time, while CNNs are used to find correlations of images. Hence, neural networks are a key foundation of artificial intelligence. Thank you so much for watching this video, and if you enjoyed this video, please make sure to like the video. And if you're new, please consider subscribing to the channel as well to stay up to date on new content that's going to come out. If you want to learn more about neural networks, check the description where I've placed a link to an article that I wrote on neural networks and a recent podcast that I've made on neural networks where I talk about neural networks as well as talk to Aniket Majumdar about the future and ethics of AI. Thank you so much for watching, and see you in the next one.